Surface areas and volumes.
Hi, welcome back to my YouTube videos. In this lesson, we start new chapter number 13, surface areas and volumes. So when we talk about volumes, the shape, the geometric figure should be a 3D figure, a three-dimensional figure. So in this chapter, we will discuss only three-dimensional figures. Of course, they will have areas, surface areas and volume. So we will discuss surface areas and volumes of 3D figures in this chapter. In 9th standard, you have studied how to find the surface areas and volumes of basic 3D figures: cube, cuboid, cylinder, cone, sphere and hemisphere. And we have made a lot of practice. But not only those common 3D figures, there are many other 3D figures formed by combining 2 or 3 of those basic geometric figures, as you can see on the screen. So for such combination of basic 3D figures, how to find surface areas and volumes? That is what we discuss in the chapter number 13. We start the lesson by revising the formulas we studied in the 9th standard. So let's start. So you can see a table. In this table, name of the solid in the first column, then a figure is given there. In the figures, the dimensions are marked, and next column, lateral or curved surface area. You know what the difference lateral and curved surface area. When we talk about cones and cylinders, we will say curved surface area for lateral surface areas. Then total surface areas in the next column, and nomenclature, the letters used to denote the dimensions. So for a cube, very simple, the lateral surface area is 4a square if the side length is a. The total surface area will be 6a square because the cube is made by 6 identical squares, right? Then for a cuboid, the lateral surface area will be 2h into L plus B. I don't explain, I hope you know, we studied in the 9th standard. And total surface area will be 2 times LB plus BH plus HL. So here you want to multiply L with other 2 dimensions, that is B and H, and B with other 2 dimensions H and L with the other 2 dimensions B and H twice. So you get 2 times LB plus BH plus HL. Then for a cone, if H is the height and R is the base radius and L is the slant height, then pi RL will be the curved surface area, and pi R times L plus R will be the total surface area. That is pi RL plus pi R square, the base area. So how is this total surface area is formed? Base area plus curved surface area. So pi R square plus pi RL will be pi R. You take outside the bracket, you will get pi R times L plus R. Therefore, a cylinder, if base radius is R and height is H, then 2 pi RH will be the curved surface area. How it is formed? This is simply the base perimeter into height. Suppose this cylinder is made by folding a rectangular piece of paper, then curved surface area of the cylinder will be same as the area of that rectangular paper used. So 2 pi R, that's the circumference of the base circle of the cylinder, will be the length of the rectangle, and H will be the height of the cylinder and height of the paper used to form the cylinder. And then here the total surface area will be curved surface area plus 2 times the base area. So that is 2 pi RH plus 2 pi R square. So 2 pi R can be taken outside, so you can simplify the formula to 2 pi R times R plus H. And for a sphere, suppose radius is R, then curved surface area and total surface areas are same, and that will be 4 pi R square. And for a hemisphere, curved surface area will be 2 pi R square, base area will be another pi R square, so the total surface area will be 3 pi R square. I hope these formulas are clear, you have memorized, and we will apply this formula to find the surface areas of combinations of some of these 3D figures.
In this table, you can also see the volumes of these figures. We don't revise the volumes right now. Maybe in the next coming lessons, we'll discuss volumes in detail, how to find the volumes of these basic geometry figures and also the combinations of such figures. So at that time, we can start volumes by revising these formulas. You don't have to wait for that. You can revise the formulas yourself, but this time I don't wish to explain it because we don't have much time.
So let's start with the solved problems in the textbook. Look the figure 13.2. So you can see a truck with a container fitted on its back. So how can we divide these 3D figure into sum of basic 3D figures? So you can see here in the next page, you can cut this container into two hemispheres, two identical hemispheres and a cylinder. Then the total surface area of this container will be, what will come? Curved surface area of one hemisphere plus curved surface area of the cylinder plus curved surface area of other hemisphere. Since these hemispheres are identical, you can say curved surface area of the cylinder plus 2 times curved surface area of a hemisphere. Now look this figure. Rashid got a plain top like this. This top is shaped like a cone surmounted by a hemisphere. So in the question, we need to find the area of this figure. So just observe the figure carefully and make some relation. What will be the total surface area of this figure? What all we need to add? And sometimes there may be something to subtract, that also you want to consider, but this one is very simple. Here in this case, total surface area of this toy will be curved surface area of hemisphere plus curved surface area of cone. So from the figure, you can find out the base radius and height. And from the given measurements, you can find out those areas, and taking the sum, you will get the area of this 3D figure. So just discuss the answer. We can just discuss the solution. Here in the next line, you can see curved surface area of the hemisphere. So we have the formula for a hemisphere. The curved surface area will be 2 pi r square. So 2 times, for pi we substitute 22/7, that is given in the question. So we use the same. Then r square. Here you can see the diameter of this hemisphere is given 3.5 centimeter in the question. So the radius will be half of 3.5, that is 3.5/2. So in the formula it is r square. So we multiply by same, 3.5 into 3.5, 3.5/2 into 3.5/2. We don't simplify here because we expect when we add the sum of areas, there will be something same that we can take outside the bracket. So now we don't simplify this step, we just keep like this. Now we go to find the curved surface area of the cone. So to find the curved surface area of the cone, you need L, the slant height, but it is not given in the figure. But we have the height of the cone and the base radius of the cone. So you can form a right triangle here, right? As you've seen in the 9th standard, you can form a right triangle with the base radius of the cone and height of the cone and slant height of the cone as the sides of the right triangle, where slant height is the hypotenuse. So using the Pythagoras theorem in this right triangle, you can find out the slant height L, that is square root of r square minus h square. So you will get the final answer 3.5 centimeter. It's approximate value. Now the curved surface area of the cone will be pi rl. Use the formula pi rl. So you will get it to d2/7 times 3.5/2 times 3.7 centimeter square. Now you take the sum of these two areas, curved surface area of the hemisphere and curved surface area of the cone. So adding these two, the common numbers you can take outside the bracket. In both these areas, there is 22 by 7 times 3.5 by 2. Those product you take outside the bracket, so you will get the next step, 22 by 7 times 3.5 by 2 into 3.5 plus 3.7. Simplifying this, you will get the final answer, 39.6 centimeter square. We write approximate inside the bracket because this is approximate value, because we used 22 by 7 for pi. Actually, pi is an irrational number. 22 by 7 is not the exact value of pi, that is just some approximation. So we have to write approx in the final answer. Now look at example 2. So here a decorative block shown in figure 13.7 is made of two solids, a cube and a hemisphere. The base of the block is a cube with edge 5 cm and the hemisphere fixed on the top has a diameter of 4.2 cm. Find the total surface area of the block. We want to find out the total surface area. So first you want to observe the figure carefully and you want to make some relation between the areas and what will be the total surface area of the 3D figure. So by observing carefully, you will get the total surface area of the given figure will be total surface area of the cube minus base area of the hemisphere. Then what you have to add, curved surface area of the hemisphere, right? Total surface area of the cube minus base area of the hemisphere. Then you add the curved surface area of the hemisphere. You look, the surface area means those whole portions we can touch by our hand. So for this cube, we cannot touch all the surface around the cube. But where we cannot touch? We cannot touch the base of this hemisphere, right? So that portion we want to subtract. And also we can touch the curved surface area, that region of the hemisphere. So we want to add that region. Now we use the formulas. Total surface area of the cube. So we have 6a square, that is the formula. So 6 times 5 square we will get 150. Then minus base area of the hemisphere, that is pi r square, we subtract, and then we add the curved surface area of the hemisphere, that is 2 times pi r square. So you look here, minus pi r square plus 2 pi r square. So that is simply 2 pi r square minus pi r square, that is simply 1 pi r square. Now give approximate value for pi and value of r, that is 22 by 7. So in the next step we will get to 150 cm square plus 22 by 7 times 4.2 by 2 times 4.2 by 2. Simplifying these, you will get the final answer, 163.86 centimeter square. Here also you want to write approximate inside the bracket, and the textbook it is missing. When you answer in exam, you want to write approximate inside the bracket because we used 22 by 7 here. Now the next question, a wooden rocket toy like this. In this 3D figure, for the conical region we want to give orange color, we want to paint it, and for the remaining part, for the cylindrical portion, we want to give yellow paint. So you want to find out those two areas separately. So what will be the area we need to color orange color? That is the conical portion. So of course we want to add the curved surface area of the cone and the base area of the cone. Do we need to color all the base area of the cone? No. From the base area of the cone you want to subtract the base area of the cylinder. So you can see here the area to be painted orange, curved surface area of the cone plus base area of the cone minus base area of the cylinder. Use the formulas and give the values, you will get the final answer. Then what's the curved surface area of the cylindrical region of this rocket? So here of course we want to add curved surface area of the cylinder and one base area of the cylinder. Only that, right? The other, we don't need the total surface area because the top side or the one of the base of the cylinder we don't want to color yellow. So you can see here, area to be painted yellow, curved surface area of the cylinder plus area of one of the base of the cylinder. So use the formulas and give the values, you will get the final answer. Now look at example 4. Mayank made a bird bath for his garden in the shape of a cylinder with a hemispherical depression at one end. The height of the cylinder is 1.45 meter and its radius is 30 centimeter. Find the total surface area of the bird bath. So observe the bird bath very carefully and make the relation. What will be the total surface area of the bird bath? So of course it will be curved surface area of the cylinder plus curved surface area of the hemisphere. So use the formulas, substitute the values, you will get the final answer. And in this chapter, you also have good knowledge how to convert areas and volumes from one unit to another unit. So to convert from centimeter square to meter square, we know how to do, right? You want to divide by 10,000. So 33,000 divided by 10,000 will be 3.3 meter square. And in some question, there may be some sub question to find the cost to paint the surface. The rate of the painting may be given like 200 rupees per meter square, something like so. So in such questions, what you have to do is the final answer, the area you want to multiply by the cost of painting. Okay, so in this lesson, I was just introducing the chapter and we discussed the solved problems in the textbook. In the next video, we can discuss more questions from the chapter. Okay, let's see you later. Bye.